So now we're recording. This is the last day of class for this mod. We have a few things to do. I do have an in-class activity. Angela will be joining us probably in about 45 minutes, and Nathan will get on when he gets on. So we will now, let me just do a quick check. We talked about that yesterday. Okay, sorry. So what we're going to be doing today is we're going to just go over word problems, how you analyze and solve word problems. And then we're going to do our in-class activity, which is a word problem worksheet. And then what I want to do, you have your assessment and the career integration quiz that you'll be doing. But I really want you to spend some time continuing to work on your portfolio assignment, because that really needs to be in as well. It'll be some work. I think Jen has already started on it.
Yeah.
She probably has an idea as to how much work this is going to end up being.
Is that due Friday or Sunday?
Sunday.
Okay.
So we will have that. The discussion, we have to, you need to post your initial post by today. Harley's already done that. And then we will go on. But what I would really like to do first is talk about the basic approaches to solving word problems. And so I'm going to bring up a document. Okay. Which is really just a list of this. I'm going to enlarge it because I know people like to be able to see these things. So the first thing you have to do, and again, read the problem very carefully. You need, it's sort of like planning a trip. Solving a problem is a lot like planning a trip. You have to know where you're going, which means you have to understand what the goal is. So reading the problem very carefully, if you have to read it 2 or 3 times, and if you have the opportunity, if you can highlight or underline parts of it that are critical, then that's a good idea. You need to watch out for words or phrases that can influence you. We saw this on Monday with the word problem that specified 2 consecutive even numbers. This, of course, is very different than just 2 consecutive numbers, because the difference between the 2 consecutive even numbers is 2. You can see consecutive odd numbers, you can see consecutive numbers. So watch out for tricky words that will change the goal or the meaning of the problem. And then ask yourself, what is it that you're supposed to be determining? If you want to know an interest rate, you know the answer is expected to be a percentage. Depending on the instructor, it can either be a percentage, which is how interest rates are normally expressed, or it can be the decimal equivalent. But nonetheless, you know what you're after. If you want to determine a distance, it's going to be miles or kilometers or meters or whatever. So you need to know what you're determining. If it's an area, you know it's going to be a square of some unit of length, and that can be any unit of length specified. Or it just could be units. If it could be, if the problem is you're given a square and you're just given numbers for the length of the sides, without units, it doesn't matter. You know that it's going to be square units. Problems should not be given to you without a unit, because it's meaningless. Okay. If it's a volume, then you're going to have cubic units be raised to the third power. So the volume of a cube is always in inches squared, feet squared, whatever. If you're working in landscaping, you're going to be thinking in terms of square yards of soil and mulch and other things that are going to be put in. So, or cubic yards rather, volumes of this stuff. And that's how it's done. You don't think in terms of weight because you're covering an area to a certain depth with material, and you calculate the volume of that. Okay. If we're looking at a speed, you know it's going to be miles per hour, feet per minute. You know, it could be centimeters per second, but it's always a distance in an amount of time, in a unit of time. And generally speaking, you can look at a problem and know what the unit of time is going to be. So, and if it's going to be something that's not obvious, it will be specified. There was a question that I used in a math class that I taught down in Denver a number of years ago that had to do with the satellite that did the flyby of Pluto a number of years ago. And so we were told what the speed of the satellite was, and asked to calculate a rate in seconds, in miles per second, or I think it was kilometers per second, because it was moving that fast. Okay. So when you were doing that, we have to read the problem. What is it you're after? If you are after a speed, figure out what they're looking for. Is it miles per hour? Is it kilometers per second? Is it, one of those things? So you want to know that. Now, sometimes you're only looking for a number. The problem that we had with the 2 consecutive even numbers on Monday was just that. We were just looking at numbers. Excuse me. Hey, Greg. I mean, yeah. I'm just going to go downstairs and. Okay. Yeah. Fine. Okay. I'll leave the door open. Just come in and out. Okay. Great. Okay. Sorry about that. One of our workmen needs to come in and go down into our basement. So sometimes you're only looking for a number. That's okay. That problem with the 2 consecutive even numbers was just exactly that. All we want is a number, no units, nothing else. So next, look at the question and and determine what kinds of mathematical operations you're going to need to solve it. The basic operations, we know: addition, subtraction, multiplication, division, and then don't forget powers and roots. Roots are things like the square root, the 1/2 power. So they're close. Use that to set up one or more equations. Why one or more? Well, I'll give you an example in a moment. But you want to set up one or more equations that fits the facts in the problem, and then solve it. And don't forget to use PEMDAS. And be very careful about using that and staying with it. And remember all the rules associated with that. Okay, so I'm going to write a little problem here that gives me that actually requires 2 equations to solve. Okay. So you have 25 coins, and these are dimes and nickels that add up to $2.10. Okay. How many of each coin do you have? Okay, so here you're looking for a number of dimes and a number of nickels. Okay. So if we have these coins, so what are that easily is easy to see. You want to know how many coins you have. This is a number. So what are the facts? You have 25 coins that add up to $2.10. So you know you have, if X equals the number of nickels and Y equals the number of dimes, then we know that X plus Y equals 25. Why? Because we have 25 coins. Okay, so that's easy to see. Now, we know another thing. The total is $2.10. So $2.10 equals the number of nickels times the value of a nickel, and the number plus the number of dimes times the value of a dime. Well, a nickel is 5 cents. So we have, and we convert that to a fraction of a dollar, 0.05 X plus dimes, 0.1 Y. Okay, so we know those two facts. So how do you think we're going to solve this?
Are you going to add?
Well, we will add, yeah. We know that we're going to have to add this up, but one of the things we do is we find a way to express, when we have two variables in a problem, find a way to express the problem in terms of one variable. Well, we have two facts. Fact number one, X plus Y equals 25. Fact number two is 5 cents times each nickel plus 10 cents times each dime add up to $2.10. So what is one way you could go about trying to solve this? Let's get an idea. So someone want to throw one out?
You can always divide the dime by each side. So that way it'll get the 10 cents off of the right side. And
So you divide both sides by 0.1?
yeah.
Okay. That's one way of doing it.
Would we multiply? I don't know. I can't explain it because I don't really understand it.
Okay. There is a very simple approach. We have one complicated looking problem with a bunch of decimals in it. We could multiply this by 100, but we still have, 2100 equals 5x plus 10y. That doesn't really get us very far. But
Right.
we know from this first question that we can rearrange it to x equals 25 minus y. Right? So now
Okay.
we have x in terms of y. Does that make sense?
No, I'm sorry. You're speaking Spanish to me.
This is an equation.
Right.
We can subtract y from both sides and it remains as an equation.
Okay. So y is what we're subtracting from the,
Yeah, we
Okay.
subtract y from each side. So x plus y minus y equals 25 minus y. So this side over here, x plus y minus y becomes simply x, right?
okay. So x equals 25 because you minus the y,
Yep.
pretty much, is what you're
X
saying
equals
in that
25
equation.
minus y. Yeah,
Okay. Because you're just showing that you minus the y from both sides.
that's right.
Okay, that makes more sense to me. Does that
So
make
then
sense, Jen?
Yeah, is everybody else on board with that?
Yep.
Okay, so now we do what we call substitution. We take this, we now know that 210 equals, right?
25. Oh, you gotta write it out.
5 times 25 minus y. Now, that's plus.
Is it 0.1? Okay.
So yeah, so we just, all we have done is replace x with 25 minus y. Now we have an equation. Oh, that shouldn't be a plus, that should be an equals. Now we have an equation that has one variable. So we simplify it. First thing we do is we clear this parenthesis out by multiplying both sides, both terms here by 0.05. Okay. Everybody with me still?
Say that again. Say that one more time for
We
me.
simplify this because we want to have this, we want to combine this term that has these terms that have y in them. Right?
Okay, right.
And we simply multiply 0.05 times 25 and then 0.05 times minus y. Does that make sense?
It's 0.05 or 0.05.
0.05. Okay, so now we'll do that. $2.10 equals 0.05 times 25. So we can pull out our calculator. And we calculate 1.25. Minus 0.05 times y is 0.05y. And then it's plus, I'm going to leave the dollar signs out because I'm getting lazy. We know that the answer is going to be that the dollar signs will cancel. Well, I'm going to leave them in because we need to understand that too. Okay. So much for being lazy. Okay. So now we combine these terms.
Okay.
Right?
Right.
Oops.
So now we would add, correct?
Right. That's correct.
The 0.05 plus the 0.0 or the 10.
Yep.
And that would be 0.15.
Now we have a minus 0.05 and a plus 0.1. So this is a subtraction. Remember, we are adding a
Decimals.
negative number, which is subtracting.
Okay.
So this becomes then, if we add 0.1 and then add a minus 0.05, we're going to end up with 0.05 y. Does that make sense?
Because we subtracted.
Yeah. Remember, adding a negative number to a positive is subtraction. We are subtracting the negative from the positive.
Right.
And I urge you, if you are, remember, if you're using a calculator, be very aware of the signs of all of your arguments, all of your numbers. Okay. So now we're going to subtract $1.25 from each side of the equation. Okay, so we have, because we want y by itself, right? So we're now going to so if we do that, then this becomes 210 minus $1.25, which is
Was $1.20 or 1.2. Oh.
2.1. We're talking about $2.10.
Oh,
Minus
we're subtracting.
$1.25.
My bad. Left to right.
Yep. Remember, if you can't do these things in your head yet, you'll learn. You're going to work with a lot of numbers. If you can't do these things in your head yet, don't hesitate to use a calculator. That's why we have them. Okay?
I just need to remember going left, staying left to go right.
Yep.
That's my problem.
So now we have 85 cents. $2.10 minus $1.25 is 85 cents. Okay, so we have 85 cents is going to equal 0.05 $sign y. So now we divide both sides. By 5 cents, basically. Okay, welcome, Nathan.
Hey,
Okay, so we're looking at a document I'm going to post in a few minutes into the instructor resources page, but it's about solving word problems. So now we're going to divide both sides by 0.05 to determine the value of y. So if we divide 0.85 divided by 0.05, we're going to get 17. So 17 equals y. I know that most of your book will try to rearrange this and tell you to put the, the variable on the left. It does not matter. 17 equals y is exactly the same thing as y equals 17. So don't get caught up too much in the order there of where the variable is. So now we have 17 dimes. Remember, y is the number of dimes. So if we go back to our original equation, which we already rearranged to x equals 25 minus y, then we get x equals 25 minus 17. which equals 8. So we now have 25 coins. 8 of them are nickels, and 17 are dimes. If we multiply this out, 17 times 10 cents is $1.70. 8 times 5 cents is 40 cents. $1.70 plus 40 cents is $2.10. So this problem has been correctly solved. So again, the logic is we have a statement, 25 coins that add up to $2.10. We determine that we want to know how many of each coin we have. And then we set X equals nickels and Y equals dimes. Could have been the other way around. It doesn't matter. So we know from the facts that X and Y, the number of nickels plus the number of dimes, add up to 25 because we were told we have 25 coins. We know that if we multiply the number of nickels by 5 cents and the number of dimes by 10 cents, it'll add up to $2.10. Now remember that we have to convert those to decimal form of a dollar. So 5 cents is $0.5, $0.05, and 10 cents is 0.1 dime or dollars. So we can then substitute those values in and create equation number 2, which was that $2.10 is number of nickels times 5 cents plus the number of dimes by 10 cents. And after that, we look for the easiest way we can solve the problem. I don't believe in taking the hard way. There are a lot of people that will do that. But the easy way is we already have this very easy equation. We could easily have said that Y equals 25 minus X. But we don't have to do either way will get us the same answer. Okay, so this time I just chose to solve X in terms of Y, and then we use the process that we call substitution. We know that this is one way of expressing X, so we can just substitute it in place of X, giving us only one variable in an equation that we know fits the problem. Then solve for that. Okay, that makes sense to everyone?
Yeah.
All right. Let's save that. Okay. So does this document, this explanation of how to look at problem solving and word problems, does that make sense? Okay. So it's a stepwise process, which starts, as so much in our life, with understanding what the problem is. You can't solve a problem you don't understand.
Sure.
In the scientific world, which is my background, if you don't understand the problem, what you do is figure out how you can understand the problem. What information do you need? This is how we work. This is why we're having so much problem with this particular pandemic. We don't understand the virus itself because it doesn't behave right by our preconceived notions. So we're still in the information gathering phase of understanding it. So in most of our word problems, everything you need to know is either there or is intuitively obvious. Like, how do you express a nickel in terms of what fraction of a dollar it is? That's something that you know from your own experience, right? So either there will be things that are based on your own experience, or they will be other things that are there will be explained to you. If you're given a problem that you're not given enough information, it's perfectly legitimate to say, I need to know this fact before I can solve the problem. And if it's something you can simply look it up. But if it's something that has to be determined by another method, then it's perfectly legit to say, this is what we have to do. Okay. So I will actually, when we take a break in a few minutes, I will actually post this so that you can pull it up and look at it if you want. So let's go back to here. All right. So this week, let's take a quick look. We looked at the discussion briefly on Monday, but what I want to do is remind you that you are looking at in your initial post, you're looking at how you feel graphs would help you make an impactful statement to your team. And then when you are doing your response, you're being asked to give a couple of examples where you would use a line graph, a bar graph, or another graph of your choice. So the issue really is that the presentation, whatever graphical method we use, should be such that it makes sense in the context of the data. There are some data that we can't graph in terms of things like line graphs, and that's things like, favorite breed of dog or something like that. There's no line graph because we don't have any order that we can put dogs into. So that has to be done by usually by bar charts or pie charts. That kind of data is called qualitative data as opposed to quantitative. Qualitative data is things that you cannot put a meaningful number on in terms of, what is the number of a husky? There isn't. And you can't add a husky to a lab. I mean, biologically maybe, but not mathematically. You can't mix them up and put them in the same bucket. They're just dogs. So we want to.
It's called mixed breeding.
Yes, I know, but that's not adding. That's not a mathematical process. Okay. You can't put a value, because the value of any one breed of dog depends on the individual. So you can't really put a value, and you can't order a breed based on some artificial value. You can in specific ways that are different, but things like that. But like sales trends could be bar graphs. They could also be line graphs. And in fact, mostly those are what you use for following sales, because you can see rises and falls of lines and follow that. And it's been very common to see those things. So anyway, you want to think about that. Then you have to think about what is the best way to make the visual image impactful. These days, we have so much more available to us than we did when I started working many years ago. We can easily construct very impactful presentations using colors and shapes and other things. But we have to be careful when we're doing that, that we don't lose our audience in the presentation so that they no longer understand the data. So you know, I've seen some things that were beautiful, but you couldn't make heads or tails of them because they were so confusingly arranged. So when we're talking about a graphic artist, remember, we're not creating art in the way that, you know, Picasso did. We are creating an information-bearing visual presentation. So don't get too artistic. I've watched people do graphs where they try to get real funny little images, and you lose it. You lose things if you get if you go too far afield. So the other obvious thing is we always follow the KISS principle. Keep it simple.
So are we supposed to put a graph in there without even having any of the data for what we need?
Well, how are you going to construct a graph without data?
You search, but that's going to take a while for all the data for each and every one.
No,
From
not necessarily. Keep it,
So-
again, keep it simple. You can
What-
go in, you can search out examples online and just cut and paste or copy and paste.
okay,
For mine, I looked up a bunch of different statistics. I actually pulled up 3 different things that I'm doing graphs on in the PowerPoint. And what I did was I looked it up online. Since it's gun violence, I went to like government websites for statistics during certain years and kind of took numbers from one year and compared them to another year so it was pretty easy actually to find the stats on gun violence because there's so much information out there on gun violence.
Do you have to do gun violence, or you
My
have to?
prompt was gun violence.
Okay, you just pick something.
Well, no, I
Are you
just went
talking-
with what was in my prompt.
Are you
Yeah,
talking about the
yeah.
PowerPoint or the discussion?
Oh, I was talking about PowerPoint. Were you guys talking
Okay.
discussion?
Yeah, we're
Yes.
talking about discussion, but that's
Oh,
a good
sorry.
example.
I was already on my assignment. I did
Ah.
the discussion part already.
I was like, I'm halfway there, girl.
No,
Which one are we on?
but that's really, that methodology can work perfectly well for the discussion. I'm not asking you to invent a bunch of data or go out and find and input a bunch of data. Just use examples. Again, don't make it hard on yourself. You know, I firmly believe that that we're given an example here. It doesn't tell you you have to use you know, put graphs into your post or your responses, although you can. I'm perfectly happy with that. But it says discuss at least 2 examples of scenarios. So you can use the visual. Visual is always acceptable because what I want you to do is get used to using these things because they're very important ways of conveying information. But it's not necessary for you to make this hard on yourself.
I think that's where I go wrong a lot. I overthink it and make it hard on myself.
Yeah, yeah. It's everybody has that that same problem. I do too. But the issue is try to read this. You're discussing the ways you feel that would be helpful. Okay, so my particular early post in this has some discussion from my point of view of how you make these things as powerful as you can. The thing to remember when you're doing this, though, think about how easy it would be to present things in a way that implies something that isn't the case. If we go back to last week's discussion, my second post had a graph of income difference between California and Nevada. And one presentation made it look visually like there was a shockingly big difference, which some people would say, oh yeah, that's California, it's expensive, so you have to make more money. But if you looked at a more complete picture, the differences were minuscule. Okay. So we can imply a lot, and politicians do this all the time. That's why you have to be careful anytime you see anyone who has a purpose of wanting to influence your thinking. You have to look, and corporations will do this as well, especially with their shareholders, to make things look better than they really are. And so you need to look very carefully at these things. And it goes back to the old saw about believe nothing you hear and only half of what you see. You know, you need to look carefully at what's being presented, how it's being presented, and sometimes ask yourself, is there an ulterior motive to the way this is being done, or is this just really an objective look at information? And as a person who spent years as a scientist, I get kind of annoyed at people who try to skew the data. So that's my problem. Okay, so let's take our first break. We'll come back and do the in-class exercise, and then I'll turn you loose to work on the rest of the stuff that's going on, and we'll talk about the assessment.
Sounds
Okay.
good.
Okay.
I'm gonna pause the recording now. So I'll try and remember to pick it back up when we come back. And Angela, you can go back and take a look later at the first hour.
Awesome.
All of this. Meanwhile, I'm going to share the screen. You have access in your shell to this in-class activity, which consists of 5 word problems. So what I'm going to do is let you guys work together on them, and I'll be staying online and monitoring what's going on because we have workmen in and out. I'll probably mute my microphone so that you're not hearing pounding and other noises. So we'll go ahead and work on that for today, and let's try and get that done in the next hour or so. Okay. If you have any questions, just ask. I will unmute and.
And he quieted himself before he could finish the sentence.
You guys want to work on this together?
Yeah.
You guys ahead of me already. You probably already ahead of me.
I have to open it up still, so.
Okay, sweet.
Don't forget to hit enable editing. I tried to type when I didn't hit enable editing.
Always remember that. That's huge. Or you don't get to fix your stuff here.
You don't get to type anything on the worksheet if you don't enable it.
Right. I know. I remember John was like, I'll promote you to my IT pro if you're right. And I was like, I'm right. And I was right. It's like, I've only done this a million times. So do you want to read it? Somebody want to read it?
I'm still trying to open it, so go ahead, I'll catch up.
Okay. Even if you want to write it down too. So 2 airplanes are leaving DIA at the same time, flying in opposite directions. one flies at 400 miles per hour and the other flies at 450 miles per hour. How long will it take for them to be at 2,975 miles apart?
So so they have to equal 200 or 2,975.
Right.
Might help if my computer is being nice to me today. There we go. And then
One is 400, one is 450 miles per hour.
and that's where my knowledge stops at the moment. I feel like I have a roadblock in my
It
head
says,
right
how
now.
long will it take for them to be 2,975 miles apart from each other? So if they're flying, one is 400 miles an hour, one is 450 miles an hour. They want to know how long it will take them. So how many hours what's the time, right? What time? The length of time.
Okay, I have it open now. So two apparent planes leave DIA at the same time, flying opposite directions. One flies at 400 miles per hour. So write down that 400 miles per hour.
Okay.
And the other at 450. So one's moving faster than the other.
Right.
So are we adding or subtracting?
Well, let's see, how long will it take for them to be?
2,975 miles apart from each other. I feel like it's missing something. It's probably not.
I agree.
Probably overthinking. But it does seem like it's missing.
Well, okay, so if you think about it, think about two airplanes leaving the ground at the same time.
Right.
And so there's two different equations there, I would say. So you got to figure out how long will it take the first airplane to fly the 2,975 miles. And then
How long it would take the 450.
second one, yeah. And there's going to be a point in there somewhere.
Mike, can you help us
I
out
think
on this one?
we need to find out what the formula would be. Is it like, do we use the distance formula? Because we need to know the distance
Right.
Yep.
between them.
Which is
Well, D equals,
RT, right?
yeah.
Yep,
Would we use that formula, Mike?
absolutely.
Yeah. So then,
And that's dividing, right? We would divide.
yeah, I don't even know what numbers for sure that we would put in. I don't know.
Okay, well, you know one number. You know the distance.
That they need to be apart
Total that
from.
we're going to be, yep. So that'd be the D, right?
You know the distance apart.
We don't know the time.
The
And we're
time.
solving for the time. Now we have
Right.
two different rates. So, but they will be flying the same amount of time. Because we're asking how long will it take for them to be that far apart? So if we use that formula, then it's going to be the sum of the distance flown by the one going 400 miles an hour and the distance flown by the one going 450 miles per hour.
So the one going faster would have more time though, right?
No, they're both flying the same amount of time. Remember, how long will it take for them to be this many miles apart? So it's the same time for both. It's
So it
just one of them is going to go further than the other.
okay.
So it'd be 400T, right? I'm not just making this up.
No, 400T and
And 450T.
50T.
Are we multiplying or adding, subtracting, dividing?
well, you're doing a little bit of both, aren't you?
Yep.
You're adding the distance, okay, the distance.
I was wondering if we were putting that add in the middle part.
We're adding together the distance that each of them flies in that amount of time, and we know how much that total is.
7.5 equals, and then it'd be 850T. Because you have to add like terms.
Mhm.
And then we divide 850 by each side, right?
Yep.
And then you'll need I have to open my calculator because I'm not doing this in my head. See, me setting something up it doesn't really work for my brain sometimes. So 3.5 is what I got. Anybody else have a different answer?
Got 3.5 also.
Harley?
Yep.
Jen?
Yep, I'm right with you.
Nathan, you with us or? Okay.
Mike, do you want us to put in the explanation like you did on ours too, or can we just do the answers?
Just do the answers.
Okay,
You've all discussed the explanation.
cool.
All right. And next one. The sum of 4 and 3 times a certain number is the same as the sum of the number and 10. What is the number? Say what?
I'm with you. I'm like, sum of what? Okay, so the sum is that,
That's adding.
yeah, that's what equals to that 10? I don't know.
4 plus
Walk me through this, Mike, please.
Well, think about it. What operation is the sum?
adding.
They equal the same thing.
Well, the sum, what is the sum? Is that, what
Sum.
operation is that mathematically?
Adding.
It's
Yeah.
adding, yes. So we're adding 4 and 3 times some number. You can call it X, you can call it N, you can call it
3
Yeah.
times. That's where you get the X.
Yeah.
Okay.
3 times is multiplying.
Okay.
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 And that's equal to whatever that number is, X or N or whatever you're calling it, plus 10.
Plus 10.
So we're subtracting 4 from each side then?
That's a good start. Yep.
then dividing x from each side.
Dividing?
No, subtracting. Subtracting.
Subtracting.
Right.
Yeah, subtracting, because that's how you got your 2x. From the 3x, you subtracted that x from the 3x, got 2x, and then you got, you subtracted it from both sides, right?
Yep.
Yeah. And then you got x equals 3. Well, the coffee must be working, Mike.
Good.
Because it's like bing, 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 fireworks.
1,500 is invested. Part is invested at 8% and part at 9%. If the total interest earned is 128, how much was invested at each rate?
Okay.
So it would
You're
be
using the interest earned as the rate times the amount of time.
You would take,
so 1,500 is invested,
Right.
but the part
part
is
is invested 8% and part is invested in 9%. So you would make two problems out of this. You're going to take 1,500 that is invested. I think you're going to multiply by 8, correct? 8%. And then you're going to take 1,500 and you're going to multiply by 9%.
Nope. Remember,
No?
part is invested, not
What's
all of
that?
it.
Oh, part. Okay.
Yeah.
So are those going to be
We're gonna
fractions?
have two equations again, just like we did in the example that I gave earlier.
Right.
no obvious.
Okay.
Thought we were gonna work on these together, but apparently not.
So that's basically what it's looking like. X plus Y equals 1,500.
Right.
Okay.
I did not get 3 whatsoever of how to figure it out. But okay,
I'm confused too.
That equals 7. Oh,
yeah.
17x. Would it be 0.17xy?
That's what I came up with.
Okay.
Well, if you,
0.17y xy.
Because if you add those together, you essentially have 17%, right?
Let's go back to the example that I put into the document about the coins. The problem with the coins, 25 coins that add up to $2.10, nickels and dimes. We have two equations. We know that the total number of coins is 25. So if we assume, and we just assume something here, it doesn't matter what we use. We use two variables, X and Y, because we want two different numbers at the end, right?
Oh, so we don't want to add them together. We want two different.
We have two different rates. So
Gotcha.
that's like the two different, different values of the coins in this one.
So
So Harley was on point when she said that X plus Y, or whatever you want to call them, is 1500. That's your first equation. The second equation looks a little like this. Remember that the formula for interest, the amount of money in interest, is the rate times the amount. Okay, the rate
Times the
times
amount,
the
okay.
amount that we're actually looking at.
So we would do, so would we times times it then?
Well, we multiply the rate by the
By the-
principal.
Okay.
Remember, the interest is the rate times the principal. The principal total is 1500. We know what these rates are, and we know that the total interest earned is $128. So the solution to this is exactly like we had with this this coin, except that we've got 128 and we have 0.08 times, say, X, the proportion of the 1500 that is at 0.8%, or 0.08, and then plus the proportion that is at at 9%, 0.09. So we have the essentially the same issue here. We know that the two amounts add up to 1500. So we have a very simple equation without all those nice decimal points that we can solve in the same way that we did this coin exercise. Does that make sense?
So we're putting 1500 plus y where x is for the second equation. Is that what you're saying?
15,
I'm lost.
No,
You
it's
lost me.
Or sorry, yeah, 1500 or
yeah,
1500.
1500 into this equation here that I'm circling with my.
Okay, so x plus y would equal 1500.
That's right. You came up with that earlier. So yes.
And then you would take and be either be subtracting.
Yep.
Because you'd be subtracting y from each side, so that way it is 1500 minus y, so that way x equals 1500 minus y.
That's right.
And then you would be putting 1500 minus y in with the x for the second equation.
Right.
Okay, that's what I was asking.
Does that make sense to everyone?
Mm-hmm.
Yeah. Oh, 4.
128 equals, I got 120 for the first little bit, and then minus, and that's where I'm lost. So 128 equals 120 minus y, I'm guessing, because can't really
I'm confused. Two.
Yeah, me too.
Okay, that's
Second
what
right along.
I'm writing it totally wrong.
And Mike has moved down to the next problem.
Ah,
We don't know the answer to 3. We're still
okay.
lost, I think.
We're cruising along.
So are we putting 120y as well, or are we just doing,
So 128 is the total interest.
yeah, I know, in the equation.
All right.
So I got 120 from multiplying 0.08 times 1500. What do we do with the extra y is what I'm trying to ask.
Just combine the terms.
Combined? Okay. So it'd be minus 0.09y,
Well,
or are we doing exponents too?
you're adding, okay, you've got, when you multiply 0.08 times 1500, you get 120 minus 0.08y plus
Okay, that's what I was.
0.09y. Don't forget to multiply times both of the components in your parentheses, right?
And 20, and then it'd be still be subtraction or addition, because it's a positive number.
You are adding
Okay.
a negative number and a positive number. So you subtract the negative from the positive.
Zero 0.01.
Yep.
So I have 128 equals 120 plus 0.01y.
Right.
Okay.
Say that one more time for me.
All right. So
You have 128 equals 120.
120, because you took the 1500 and the minus y and you put it in with x, or where x was in the second equation.
Mhm.
And then you multiply 0.08 to 1500, and you multiply 0.08 with y, which gives you 120 minus 0.08y plus 0.09y.
Okay. I just want to make sure I heard.
Okay.
Thank you.
And then you take, I want to say you subtract 120 from each side. But look, Mike is giving. Doesn't seem like that's the correct thing to do.
Your face says it all.
Or subtracting or dividing 0.01y. There's more ways to do this than one. We have to get y by itself.
Oh, I thought that was me.
So are we subtracting 0.01y, or are we dividing it?
Well,
Just
how are you
divide
going to get y by itself?
You have to divide it.
Right.
That is a big number. Everybody get 12,800 for our dividing 128 point divided by 0.01.
Well, that's more than the total investment.
I know.
When you eliminated the 120, remember, you can't just subtract it from one side.
I'm not.
Well, you did. I mean, if
I divided before I subtracted.
back up a little bit, you got to the point where 128 equaled 120 plus 0.01y.
Mm-hmm.
What do you do to get y by itself?
Divide.
No, you've got a 120. You've got a plus term there.
Oh,
You've got to subtract it from both sides.
Right.
And then you divide the 0.01y. That's what I was asking myself earlier, what to do first.
Well,
And that is why when
okay.
That
I
is-
thought you had already subtracted the 120.
no, that's why I was lost.
Okay.
and also for the worksheet for last week, that's why I said that it was too high for the second problem for the answer that I got on there
Yeah.
because it was more than the investment.
Shouldn't have been. The answer should have been in the range of 41,000.
I got it was $1 less for the investment for the first time that I did the equation.
Now, well, then I don't know how, I can't remember how you set that up. Or no, you didn't explain how you set that up. You just said that it was too high, which is actually something that is a good idea to look at. But you remember that compound interest is always front loaded. So you're going to pay very little interest in the early part of paying off any loan, whether it's a 3-year loan or a 30-year loan. Very little interest in the first period of time. That's why if you look at a house, say you buy a house for $100,000 at 5%, you're going to look at it and say, I only paid off about $50 in the principal because all the rest was interest. It takes, in a 30-year loan, it takes about 20 years to get to the point where you're paying more principal every month than interest.
Yeah, but with a 3-year loan and with interest, it shouldn't take $1 for each year.
No, it won't. So I don't know. I didn't see what your calculations were, but the a $50,000 loan at 3 years after paying for one is probably going to be in the range of $40,000 left on the balance at the end of the first year. You'll be paying much more and paying it down much more quickly after that. But anyway, that's what, that's last week's. And
Yep.
but that is something that is real. And a lot of people don't understand that. But it takes a while to get to the point where you're really making a dent in a loan that is compounded.
Okay, I only see 2 numbers in number 4.
That's right. That's all you need. We have 3 components to an area calculation. Area is the length times the width. You have a way, you've got 2 formulas you have to come up with. One is the length we know that the length is twice the width, and the other, we know that the length times the width is 112 square inches. So we have two equations.
My head is going to explode.
So if it's 112 square, is that, I don't even know what I'm trying to ask you.
What's that, Harley?
I don't even remember what I was trying to ask you. Oh, the 112 square inches?
Yeah,
Now, is that multiplied?
that's the area. That's the length times the width.
The area would be 112 square?
Yep.
No, that square, that's the same as if we were to square it. Or no? Like to the power of?
Well, no, that's just the square inches. Don't worry about that. You're not squaring a number to do that.
Okay, that's all I need to know.
Yeah.
And the length of the rectangle is 2 inches less than twice its width.
Yep.
So you need to find the width.
And the length.
Yeah, I was gonna say.
This is not a fun one.
It might be. I think we're overthinking it.
I usually make 6 tablespoons and a cup and a half of water. Okay.
So what do we know?
Well, we know that we need to figure out what the length is and figure out what the width is.
2 times less, so it'd be a negative, right?
I meant for plugging it into the problem.
I think so.
So we know that the rectangle is 112 square inches.
And we know that the length of the rectangle is 2 inches shorter than twice. So we need to know what the width is first.
Yes.
And then we need to figure out what double the width is and then minus 2.
Right.
And you lost me.
I think if we find the length, the width will be there.
I think it's you're backwards because we
Oh yeah.
need to know how much. Yeah. So we need to figure out what the width is before we could figure out the rest of the problem. So that's your first half of the equation, I would imagine.
So I got 112 equals L times 2W.
112 equals area. Or wait. What
112 is the area, L
Right.
is the length, and W is the width.
Right.
That's how I'm writing it. That's how I wrote mine, was 112 equals L times 2W, because it's 2 inches less than twice its width. But I may be wrong of how to write this out.
It'd be length times width.
Times height is normally what you do when you have a square or a cube. Square inches normally means it's cubed.
Nope, squared, square inches. Area is always just squares. There's no cubed involved.
Mm,
More simple than we're making it, isn't it, Mike?
Yes.
So do we take 125 and multiply by 2 to get the width? Or not by 2, but I just had it and I can't even put it into words.
Okay.
Okay, 120 or 112. We're multiplying, right?
mhm.
Yep, we are multiplying, but what's the relationship between length and width?
There is no relationship. I mean, there is a relationship.
It's right here. It's in this first.
2 inches less than twice its width.
Right.
Length is less than the width.
And
2
twice.
inches less.
Twice.
What does 2 inches less mean?
Take subtraction.
That's right. So it's twice the width, but minus 2. Okay.
So I still have 112 equals L times 2W. That is what I have. I'm guessing minus 2 is at the end.
Let's look at this again.
I hate geometry. Just putting that out there. I've always hated geometry.
Let's look at the logic of the first sentence. What can we say that L is?
The length as 2 inches.
Is 2 inches less than twice the width?
So
You
is it
need to
negative
look at
2?
this entire phrase.
Are we going to multiply 2
2 times what?
by itself? 2 times 2.
Why?
Because it's twice its width.
Twice the width. Okay, how do we write twice the width?
2 times.
2W. Okay, and what's the rest of that sentence telling us? We have one more component to this.
The area.
No,
Of
Are we dividing the area with the
no, no,
width?
no, no. What's the rest of this first sentence
Two.
telling us that how to calculate length? It's 2 inches less than
less.
twice the width. So what is L?
2W minus 2.
Right. Okay. So now we have what we need to solve this problem. Now, it will come out to be a quadratic equation. You can either use the quadratic equation solver that I gave you a reference to on Monday, or you can just leave it at that. We're not doing quadratics here. This is more a case of how do we set this up for solution.
So that would be our answer.
Well, do the final equation. We still have to plug that into the area. Okay? The area is the length times the width. We know what L is. We can substitute what we've already calculated for L into this formula and come out with with something that has an answer. So substituting here, and it'll only be in terms of W.
It'd be 2W squared because we're multiplying, right?
Mm-hmm. 2W squared, and what else?
Minus 2W.
Right. So you got that by multiplying 2W minus 2 times W. Right?
Mm-hmm.
Can you explain that to me?
Okay, we are linked. What we've done, again, we have calculated L, just like we did up here. We've calculated, in this particular problem, we calculated X, and we created something that puts it as in terms of Y. Down here, we're given that information. We're told that the length can be related to the width by this formula. Twice the width minus 2. Then we simply substitute this value into the area formula and multiply by W. So then, and W multiplies times each term here. Don't forget that. So we get 2W
Power.
squared minus 2W. So I'm going to encourage you to stop here at 112 equals this formula.
It's 2W to the, or 2 to the power of W. Take away 2W or subtract 2W.
Yeah, that's exactly right. That can be rearranged in any way you want, but this will be good enough. The issue is the logic of setting up the problem. And as has been said, you can put this into that quadratic solver and come up with an answer. Or you can just leave it there. I don't particularly care. I'm more interested in your thinking on these problems.
So for 5, product of 2 consecutive odd numbers is
1 less 5 times their sum.
Yeah.
What are the numbers?
so we have 1 and we have 5, and we did have one like this earlier. Would it be 5x minus 1y? I want to say that, but
What is the sum of X and Y? Just not as numbers. We don't know those numbers, but what does the sum of X and Y mean?
1 less than 5, so 4.
No, what does the sum of X and Y. We're talking about their sum, X and Y. These two
That's
consecutive
addition.
odd numbers.
I don't understand this one.
What operation is implied by the word sum?
Addition.
Addition.
Sorry.
So the sum of X and Y is X plus Y. So now we move out from there to 5 times X plus Y. Right? Then we have to subtract 1 from it. And then let's back up to the beginning. What does product mean?
Multiplication.
Right. X times Y. So we're told that X times Y equals the rest of this.
X plus Y.
Fine.
X times Y is equal to what we just calculated from this part of the question. 1 less than 5 times their sum. Right?
So negative 1, I want to say negative 1x times 5y, but
Why are you saying negative 1x? Where does that come in?
because it's 1 less than 5.
No, 1 less than, and then this is a phrase here, 5 times their sum. Don't get confused.
5 times, so it's 5 times it'd be adding, right?
No, 5 times, what is times?
A times, a multiplication,
Multiplication.
right?
And we're multiplying their sum, right? We've already determined what the sum of X and Y is, right? And I don't mean the actual numbers. I mean, how would we represent that in an algebraic formula?
Addition.
Plus
Right.
y equals x times y.
Pardon? Say that again, Anna?
X plus y equals x times y.
No,
Oops.
we're
I'm
not,
getting-
we're not told that. X times Y, the product, is equal to this entire thing that we just spent a little while constructing.
So the X plus Y. And then would it be times 5 minus 1?
Times 5 and then subtract 1, yes. There you go, Angela.
We just leave it like that. That's
Well, you can solve it.
we solve
We
it.
also know, okay, we know 2 things. 2 consecutive odd numbers. Okay? That means that there is a difference between them of 2.
Oh. Okay.
So we know
Consecutive.
that one of them is 2 plus the other. Okay? So we have 2 equations. They look a little more complicated than they actually are, because again, we can calculate from knowing that 2 consecutive odd numbers are, one of them is 2 more than the other. 1 and 3, or 3 and 5, or 39 and 41. All of those are a difference of 2. So we have 2 equations, and we just put together one of them. This is the other that will help us solve it. And again, we can solve the simpler equation you know, say x equal y plus 2 for, yeah, we know we have that right there. We know that x is y plus 2, so we can simply plug that into this formula, the second one.
I don't even know how you
Can you
guys are
show me?
doing that.
Sorry.
Say that again, Anna, please.
I don't know how you guys are getting it. Really don't understand.
Okay. Where are you losing us?
It's just not making sense to me. It really is not.
Okay. Are others getting this and maybe can help Anna? Because I'm not sure. I mean, I'm not getting this. Doesn't tell me where I've lost you.
I'm struggling to understand it too. If you could show me, I would understand it better.
I feel like I don't understand it enough to explain. I'm kind of starting to get it, but
I'm with Angela right there. I'm kind of in the between with Angela and Anna right there. I'm like, huh? Poor Anna's in tears. I'm sorry, Anna. I'm with you.
That's how I felt about number 3. I'm still confused about that one.
I think he went in and finished. He was finishing number 3 when we were working on 4.
Oh, okay, yeah, I see it now. Cool.
You were
I feel
working.
like you can explain it better when you show me, because I'm just such a hands-on that I need to
Right.
see it, to visualize it, to know it, and to build
Okay.
that fatty
So
tissue
if
in
we
there.
if we go down here, we're on number 5. If we let's just start tearing the problem apart. 2 consecutive odd numbers. Let's just stop right there.
Okay.
If x is one number and y is the next odd number, then y equals x plus 2. Does that make sense?
Where are you getting the 2?
Yeah, that's
Odd numbers are 2 apart. 1 and 3, 3 and
the
5,
2
5
in
and
the
7.
wording. It's
Again,
just because the
look
2 isn't
at
a
the
2.
wording.
Yeah, it's in the wording.
It's in the wording here. We
We're
have
not taking it out and putting it as a
odd
number.
numbers. Odd in this case means uneven as opposed to strange. Okay? So that is something that tells us that if we randomly say that x is our first one and y is our second one, then y has to be x plus 2. Has to be 2 more than x. Right? So that's one equation. Now, if we look at this second one, and let's just say we're looking at now, let's take the, let's just ignore this particular part of 2 consecutive odd numbers. The product is multiplication. And we're now multiplying these 2 consecutive odd numbers of y and x. So x times y, word is such a pain. Word is a pain.
Yes,
So
it is.
x times y is equal to, and we've already talked about their sum, okay? So it's 5 times the sum. So x times y is this case, we've got x plus y, and we're going to multiply that times 5 times the sum of x and y. And now we're going to subtract 1. Anna, is this making a little more sense?
No.
Okay. What part of it is not making sense?
Well, I'll just end up figuring it out myself because that's what I've had to do through all of my school. Because the teachers normally don't know how to help me with learning new things.
Okay. Yeah. Okay. Okay. So Anna, I want you to do a couple of things. Let's just, first off, let's take a couple of deep breaths to calm down. I think you have, you're getting upset, and I understand that, and that's not unreasonable if you're having trouble. But let's see if we can calm down. There's a couple of things that we use for doing this. One of them is to take a few deep breaths. Another is to stand up and alternately touch one knee, touch your right knee to your right hand to your left knee, and then left hand to right. Do that about 10 times. This kind of moving across your midline is a calming and recentering effort that can help you, back down and get away from being upset. So
I'm doing it with you, Anna.
Pardon?
I'm doing it with her.
Good, excellent. Thank you, Harley.
Absolutely.
Yeah, it helps it when you go across your midline, it really helps your brain function better.
Yoga helps too. This is why I love yoga.
Can we actually take like maybe a 5 minute? I need to use the restroom.
Yeah, go ahead.
Act like an official
You're not
break.
allowed to pee. What's wrong with you?
That's right.
Go ahead.
I'll miss you.
So take 5
Okay, I'm gonna take a break too.
or 10. Take 10. We need a 10-minute break, I think.
Okay.
Resume the recording before we go on. So what I suggest is that you look at this. I will put up the solutions to the point of getting to an area like here to a quadratic equation that we won't be solving because quadratic solutions were not part of the curriculum for here. And in fact, you probably won't ever use them in business.
What about in IT?
You might use them in IT, but it depends on the kind of programming you're doing. If you're doing scientific programming, then yes, you will see them. If
So
you
I mean,
business programming, you won't.
I won't see it.
Yeah, you probably won't see them because I don't know of anything that actually, except for complex economic modeling, which I don't see. You'd have to have a lot more mathematics than we are giving you here to do that. I don't see the use of these kinds of equations, but the fact that they exist is important. And is a part of understanding, understanding algebra itself. So, but the actual solution, as I said before, you can plug it into the algebra, the equation, the quadratic equation calculator that is accessible through some of the resources I posted, I think last week or maybe Monday. But the information is there. It's easy to do, but there's no reason to go through the complicated method of solving quadratic equations, not in this class, okay? So I'll have all of that up. So questions? What questions do you have?
So far, we good.
So far, so good, Nathan. Thank you.
Yeah, I'm good too.
Me too.
Okay. Angela, how are you doing?
Good. I just have a few things to catch up from last week, and I'm pretty much all done with this week's stuff, so that helps. I just have that week 3 assignment that I need to do.
Great.
Otherwise, I think I'm okay.
All right. Good.
I did notice that I don't see a spot for us to submit that worksheet for the in-class activity.
I will make sure that it's there and submittable.
Okay.
I may have to go back and check that because I thought I had it set up, but I might have missed it. So I'll get that done. So don't worry about that. So what I was going to say at this point is let's go back to look at the here we go. Let's go back and look at week 4 briefly. You have an assessment. The assessment consists of 7 problems or 7 questions that you have to write a short essay for each to explain. So let's just take a look here. And actually, I can do this. Can everyone see this? Okay. So this is what they will look like. There will be a question, and then you'll have a dialog box. That means I'm going to have to grade. It's going to have to grade every one of these separately, but that's okay. I'd like you to make your responses substantial enough that I can see that you understand the question. I'm not terribly angsted about 100 words. But I need to know that you understand the question so that I can properly grade each one. There are, as I said, 7 questions, and they cover the various equations. I don't understand the insert math equation feature. I don't have that on Word or anything else, and I don't see it as something I can add to Canvas. So just pick an equation and write it out. Okay. And it can be a simple equation. You can use one of the equations that we've worked with during the course of the this mod. So inserting graphs and so forth. Here's how where you find an example of a graph online, copy it, put it into your response here, and then interpret it. Discuss how you want to interpret it. Okay. So it'll be 7 of those questions that require some writing. So you need to go ahead and get started on that as well. Does that make sense to everyone?
Yeah, that is due when?
Sunday night.
Sunday. Okay. Awesome.
What about the discussion post?
Discussion
Sunday.
post.
Or Wednesday.
Yeah, we have that as well. The discussion post, the original post is due today, the first post, and then you need your responses by Sunday night. Everything is due Sunday night. Okay. And if you can get it in before then, please do, because I also am setting up my 2 classes for next mod this week. So, questions, thoughts, concerns?
Not yet. I think I've got it I think I'm pretty clear on everything else that we need to do.
Great. So what I'd like you to do for the next roughly half hour that we have for this morning is work on your portfolio assignment and discussion for those of you who haven't submitted a discussion yet. And if you have time, get started on the assessment. I suspect the assessment will take a while. So what I suggest you do, quite frankly, is copy down the questions and work on those answers offline. Okay.
Okay.
And let's take a look here. Let's look at the in-class activity. Okay.
Oops.
Then this is now. Okay, so you'll be able to submit at least for this section of the class, and I'll get the other one done as well. So you can submit that. If we go back now, let's see. Let's just make sure that the assessment, what I'm going to do.
Be quiet about it. Get my rights violated, but I gotta be quiet.
I'm going to give you 5 attempts on the assessment, not because I think you'll need it, but because if you go in there and copy the questions to something else to work on them offline, that'll count as a first attempt. So I'll let you do that. Oh, 5 questions, each worth 7 points. That's better. 5 questions. Thought it was the other way around. All right. So that's what I suggest you do the rest of the morning. I will be here to answer questions. Okay. Any other thoughts or comments?
Not for now.
Nope, I'm good too.
Okay. So I'm going to stop the recording. Because I don't know that we'll need it.